Students, this question was asked in the year 2021. Match the columns. In column 1, given capacitance, epsilon 0, the electric permittivity of free space, mu 0, magnetic permeability of free space, electric field. Okay, students? And 4 options are given in column 2. Let us find out the dimensional formula of the following 4 physical quantities starting from capacitance. What is the formula for capacitance, student? We know that is Q by V, or the capacitance of the conductor is the charge required to increase its potential through 1 volt. Okay, student? So we may write this as Q into Q by V into Q, and this becomes Q square by QV. And what is QV, student? QV is the work done to take a charge Q through a potential difference of V in an electric field. Okay, student? This is work done W. So what is charge? Charge is, we know, the current into time. So we write here AT to the power 2, and for W we write NL2 T minus 2. This is the dimensional formula for work, student, which is force into displacement. So this is, students, A2 T to the power 2 upon ML2 T minus 2. This becomes, student, N to the power minus 1, L to the power minus 2, T to the power 4, A to the power 2. Where is it? Minus 1, minus 2, 4, 2, minus 1, minus 2, 4, 2. Here is it. So A connects to 3 students. Let us then find out the dimensional formula for epsilon 0, that is in the electrical permittivity of vacuum or free space. Where can we get the formula for epsilon 0, students? We have studied Coulomb's law of electrostatics. What does that law states? F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So, students, epsilon 0 is equal to 1 by 4 pi F Q1 Q2 by R square from this formula. Okay, students? Then what will be the dimensions of epsilon 0? Dimension of epsilon 0 will be equal to dimensions of 1 by 4 pi into dimensions of 1 by F into dimensions of Q1 into dimensions of Q2 upon dimensions of R square, students. And this is 1 by 4 pi is dimensionless. 1 by F means 1 by MLT minus 2, and that of charge, student, we know that is current into time into current into time. There are 2 charges upon L square. Okay, student, this becomes A square T square upon M L cube T to the power minus 2. So this becomes, student, M minus 1 L minus 3 T. This is T minus 2. So this becomes T minus 2. One goes upside. This becomes T4 and A to the power 2. Minus 1 minus 3 4 2. Minus 1 minus 3 4 2. It is in option 2. So B connects to option 2. Okay, students. Let us then find out the dimensional formula for magnetic permeability of free space. Okay, student. Then what is the magnetic permeability? How can we find it? That is mu 0, and we can find the formula for mu 0 from, students, Biot-Savart's law. Okay, student. Suppose this is a current carrying conductor. I current is flowing through it, and this is a small element, line element dl. Suppose there is a point P here. It is specified by this radius r and this angle theta. P is at point r theta. Okay, student. Then what will be the magnetic field dB due to this current conductor, students? That is given by Biot-Savart law. dB is equal to mu 0 by 4 pi I dl cross r by r cube. Okay, students. Then I think the ink has gone. Student, let me change one marker pen. Okay, student, I am back. This is dB is equal to mu 0 by, so we may write dB is equal to mu 0 by 4 pi I, and this dl cross r means this is the cross product of two vectors dl r sin theta by r cube. So student, this r will cancel this r cube, this will become r square, or this becomes mu 0 I sin theta upon 4 pi r square. Okay student, then what will be the value of mu 0? Mu 0 will be dB into 4 pi r square. Okay, this will get multiplied upon what is in the upper side, that is I dl sin theta. Here is dl student, I dl sin theta. So this will be upon I dl sin theta. And so the dimensional formula for mu 0 will be equal to student dimensions of dB of dimensions of 4 pi into dimensions of r square upon dimensions of I, dimensions of dl upon dimensions of sin theta. So you know student, the dimensions of 4 pi is dimensionless because 4 pi is a number. Sin theta is also a trigonometric ratio, and this will be dimensionless. Then what will be the dimensions of mu 0 student? That will be equal to dB. We may write here B, the magnetic field, into, we may neglect this, I will write L square for r square, and I current A, dl means L length element, and sin theta we will ignore it. Okay students, then this becomes L will cancel out this square, this will be B L to the power minus 1. Okay student, and what is B? What is the dimensional formula for magnetic induction vector? B student, we know the force due to an magnetic field on an electric current carrying conductor of length L in which I current is flowing is given by BIL. The force is B times IL, where student B is the magnetic field, I is the amount of current flowing through the conductor, and L is the length of the conductor. This is the force on the current carrying conductor due to the magnetic field. So B is F by IL, or the dimensions of B will be dimensions of L upon dimensions of I multiplied by dimensions of L. This is MLT minus 2 upon A, and this is L. Okay student, then this becomes LL cancels out, this becomes MT minus 2 a to the power minus 1. Here we will write for B MT minus 2 a minus 1, and this is a minus 1. Okay student, there is one L here, so we will write MLT minus 2 a minus 2. This is the dimensional formula for mu 0. Here it is wrongly written student, this is 1. So 1 1 1 1 minus 2 minus 2. This is the formula for mu 0. So C connects to 4. Okay student, let us now find out the dimensional formula of electric field. What is the force on a charge in an electric field student? That is given by F is equal to QE, the force on a charge in an electric field. This is the charge, this is electric field, the force is Q times E. Okay student, then from this we can find out the formula for E as F by Q. So the dimensions of electric field will be dimensions of force upon dimensions of charge, and dimensions of force is MLT minus 2 upon dimensions of charge is 80 student. So this becomes ML T to the power minus 3 a to the power minus 1, or 1 1 minus 3 minus 1. So here it is 1 1 minus 3 minus 1, it is in 1. So D connects to 1 student. This is the correct answer.